Ladies and gentlemen, today is Friday, finally Friday. I feel like playing that, who sings that song Friday? It's Friday, Rebecca Black. I will spare you the Rebecca Black impersonation, and I will just tell you today is Friday, and it's a day of celebration. We have 7 questions here from 5.1, a review of our learning in 5.1. We'll correct it together. The first question asks us to define these 4 vocabulary words, and the first one being a term. A term is an expression. And when we say expression, it's the math equivalent of a word, right? So like in 3 plus 4, that's a mathematical expression. 3 is a word, 4 is a word. Together they make a sentence, 3 plus 4, right? We can think of it that way if you want. It's 2 words. So an expression, the whole thing is an expression. An expression created or made up of, created by the product. A product is a fancy word for what, Jack? Product, that's the elf on the shelf. Created by the product, which means multiplication of numbers, letters, which of course, when we say letters, what do we really mean? We really mean variables, right? Or both. Mostly they're both. So an expression created by the product of numbers, letters, and or both. So for example, here's 3 examples. -4 is a term, comma. X is a term, comma. -3x is a term, comma. 4x squared yz cubed is a term. Because if we think about what this would be right here, -3 times x. That's the product of a number and a letter or a variable. This would be the product of 4 times x times y times z times z times z, right? The product of numbers and or letters, when we think about what that is. A polynomial is an expression or a sentence, a mathematical number sentence, an expression made up of more than one term. So if you have 2 terms, it's a polynomial, but it's also, you can call it a binomial if you want. If it's 3 terms, it's called a trinomial. And once we get past trinomial, we don't have quadrinomials and quintinomials and sextinomials. They're just called polynomials. But you can call a polynomial anything more than 1 term. The degree of a term is determined by the degree of a term, G.E.G. Durger, Dr. Dre, degree, D-E-G-R-E-E, the degree of a term is determined by the sum being adding, the sum of the exponents on the variables, double underlined in the term. That's a long sentence, but you get the idea. So the degree of a term is determined by the sum, adding together, of the exponents on the variables, double underlined in the term. So for example, let's look at this term, -4. What is its degree? 0. Why, Avery? Why does -4 have a degree of 0? Because there's no variables. And if there's no variables, you can't add the exponents on the variables if there's no variables. Danny Kim, is that a term? Yes. Is that a variable? Yes. Does it have an exponent? Yes. So therefore, what is the sum of all the exponents on the variables within that term? 1. It's invisible, and we don't write it, but we know that that would have a degree of 1. What about this one? Hayden, what's the degree of that one? 1, because it only has a variable. More complex would be identifying the degree of this one. Avery, what's the degree of that term? 6, because we have an exponent of 2, we have an invisible exponent of 1, and we have an exponent of 3. Adding those together, that would have a degree of 6. Everybody good with that? Now that's different than the degree of a polynomial. In this example up here, all of these are just terms. They're all one-term monomials or one terms. When we have more than one term, meaning a polynomial like x plus 1 or x squared minus 3x plus 2, in these polynomials, the degree of a polynomial is determined, and then I'm going to put in big capital letters, not by the sum of all, big bold letters, exponents in the polynomial. That's a lot of words, but you know what? It's important that we polynomial. So the degree of a polynomial is determined not, double underlined, by the sum of all, double underlined, exponents in the polynomial, comma, but rather the term with the largest degree. That is a beautiful definition of what the degree of a polynomial is. So if we look at our two examples here, what type of polynomial is x plus 1? It's a binomial. It has two terms. The first term, x, has a degree of 1. The second term, 1, has no degree. In this example, you're like, well, 1 plus 0 is 1. Well, the degree is 1. But it's not x 1 plus 0. It's like, which one of those two numbers is the largest? It's 1. Therefore, the degree is 1. If we look at the next one, what's the degree of this term? 2. The degree of this term? 1. The degree of this term? 0. So therefore, by our definition, what is the degree of that trinomial? 2. Not the sum of all the degrees, but rather the degree of the term that has the largest degree. Okay, those are our definitions. That was 7 minutes of definitions. Question 2, what is this? This is a monomial, and I'll write it in red. We're just going to define it using our big boy and big girl words, monomial. This is a monomial, just one term. This is a binomial because there's two terms. And this is a trinomial because there's three terms. What is the degree? Well, invisible ones are here and here. The sum of the exponents within that term means that this has a degree of 2. In B, there are no variables, and since you need a degree to have a variable to have a degree, it does not have one. In the second one, or third one, a degree of 2, degree of 2, degree of 0. So the whole trinomial has a degree of 2. Degree of 3, 1, 1, 1. Degree of 3, 2 and 1. The binomial has a degree of 3. You see? Hee hee. Interpret. This is an x squared tile. These are negative 3x tiles, and this is a plus 3. So when I squeeze that all together, I get x squared minus 3x plus 3. A trinomial, right? Even though there are 1, 2, 3, 4, 5, 6, 7 shapes, when I interpret it, it still becomes a trinomial, right? Here, negative 3 is 3 little small squares. Positive 4x. That's the positive. So this is the negative 3, the positive 4x. And the negative 2x squareds, remember, if they were shaded in, they would be a positive 2x squared. And if they're not shaded in, they're a negative 2x squared. So that would be the a graphical interpretation of that trinomial. Define each part. 3 is your exponent. Now, if you didn't get exponent there, you're in trouble because we spent an entire month studying chapter 3 on what was called exponents. So if you didn't know 3 was called an exponent, you've got some learning to do. 5 is your coefficient. Negative 4 is your constant. These are words from grade 7 and 8. And x is your variable. To be totes honest with you, all four of those words were probably learned in grade 7, definitely in grade 8, and just reinforced here in grade 9. And your last question says, make a polynomial that has the following 5 criteria. Has 2 terms, has only 2 variables, has a degree of 2, has a coefficient of 1, has an exponent of 2. Well, this is interesting. This one here is going to change a lot of what we have to do. Has an exponent of 2. Because originally, I was thinking this, correct? That has 2 terms. Does that work? I have 2 terms and 2 variables. Are these 2 still okay? Okay. But does it have an exponent of 2? No. What if I put a 2 here? Does it meet this one now? Yes. Does it still have a degree of 2? Yes, it does. And does it have a coefficient of 1? Now, I went around the room and I saw a lot of this stuff going on, right? You don't need to write coefficients of 1. They are understood to exist without you having to beat somebody over the head and say it's there. Now watch this. What about this one? 2 terms, 2 variables, coefficient of 1, degree of 2, exponent of 2? No. So that one doesn't work because it doesn't have an exponent of 2. There are various other ones I'm sure you could have, but you get the idea of what you need to write if you wanted to write one properly.